We physicists say, follow the information. This is whenever we've first had an Earth-like planet in the habitable zone of a Sun-like star. Yet, what's exciting is NASA has found a super-Earth that could have conditions to support life. The new exoplanet is 137 light-years away, or about 800 trillion miles. Cosmologists say the planet is around 1.2 times the size of Earth and circles a little ruddy star that is cooler than our Sun. Very thrilling. I mean, we haven't found an exact twin of Earth. This is definitely not an accurate copy, yet out of this most recent corridor of 500 new potential planets, undeniably greater than Earth, around half greater, it's significant. NASA's James Webb Space Telescope has scarcely woken up, and the universe is proving to be more mysterious and gorgeous than humanity's wildest dreams. This is an enormous discovery, and we feel that it's a gigantic revelation. The most exciting part of this striking instrument we've placed in space is finding things we didn't expect, things we can't yet explain. This forces us to change our understanding of the universe. JWST is remarkable to such an extent that, if you invest enough time, you could probably find any system that ever formed in the universe. It's actually that powerful. Right now, headlines are circulating online, claiming that the James Webb Telescope has detected a bright array of artificially produced city lights on Proxima b, answering one of humanity's oldest questions. For this scenario, we would clearly not be alone in the universe. However, what is the true foundation of this pivotal claim? Can we prepare ourselves to connect with extraterrestrial neighbors? Or should we treat these sensational reports with a healthy dose of skepticism? When we hear the buzzword extraterrestrials, we often imagine highly intelligent beings with advanced technologies beyond our imagination. However, experts take a slightly different approach in their search for extraterrestrial life. It isn't always about advanced beings embarking on interstellar journeys aboard futuristic spaceships. The search for extraterrestrial life includes chasing after microbes, microorganisms, algae, and plants just as much as searching for fully developed civilizations. No surprise, Earth remains the only known celestial body in the universe to have produced both simple and complex living things. Yet, we face a significant mystery. We still have no clue why and how life unfolded on our blue planet or how it ultimately overcame the hurdle of intelligence. For billions of years, Earth was home only to microorganisms, plants, and animals. It is only in a blink of an eye in Earth's history that one branch of life evolved into a species capable of creating technological marvels like the James Webb Telescope. Despite our most powerful space telescopes, we cannot fully define what intelligent life truly is, let alone speculate on whether intelligent life beyond Earth would resemble what we know. Without any comparable discoveries, we ourselves remain the only clue available in the search for unknown neighbors. Thus, the search for extraterrestrial life often centers on the question, what factors are necessary to enable the flourishing of Earth-like life? Regarding humanity, we can likely agree that we are not friends of the dark. We have always battled the darkness of night, first with fire and later with electric light. Today, our bright traces are so pronounced that they can be seen from space. While the brilliant night sky once released a staggering exhibition of light for our ancestors, in many cities today, it can only be witnessed through reduced light pollution. Based on this, assuming that other civilizations in the universe have followed a similar path, the question arises: might there be planets that shine artificially, and would we even be able to recognize this? Fortunately, we are not the only ones exploring this subject. The topic of alien techno-signatures is far from new in professional circles. A few years ago, Eliza Tabor of Stanford University and Harvard professor Avi Loeb considered whether it would be possible to detect the obvious light trails of a nearby exoplanet as part of a research study. Their work focused on Proxima b, a planet lying just 4.2 light-years away, essentially close to home. However, we should note that 4.2 light-years is still a significant distance, around 37.8 trillion kilometers. With current technology, it would take centuries to reach Proxima b. Luckily for researchers, their theoretical considerations didn't require venturing into the infinity of space. Assuming that this extrasolar world is indeed graced by a highly developed alien civilization with brightly lit cities, could we detect them? The answer is no, not directly. Even the most powerful telescopes of our time cannot capture a hypothetical sea of lights on film. However, it's possible to approach the subject indirectly by measuring the light reflected from its host star, Proxima Centauri. More precisely, we can predict the average value within a certain range. If actual measurements exceed theoretical expectations, this could be due to artificial lighting. What better instrument to detect this than the revolutionary James Webb telescope? After all, Webb is up to 100 times more sensitive to electromagnetic waves than its predecessor, Hubble. In theory, it could detect the heat of a honeybee on the moon's surface from Earth. In practice, however, Webb has been providing us with spectacular images from space for over 2 years, continuously reminding us of how much we still have to learn about the nature of the universe. For example, Webb has detected impossible galaxies that, with their formation just a few 100 million years after the Big Bang, appear too large and massive, earning them the nickname galaxy smashers. Elsewhere, Webb's measurements have confirmed the so-called Hubble tension, showing that the universe is currently expanding faster than our theories allow. Clearly, this $10 billion instrument has the potential to challenge our established assumptions. But what has Webb found regarding artificial city lights on Proxima b? Nothing at all. However, we do know that Proxima b is listed as a potentially habitable world. Proxima b orbits its parent star in the habitable zone, at a distance that allows liquid water to exist. However, the presence of water alone isn't enough. Other factors, such as atmospheric conditions and radiation from Proxima Centauri, could still make life impossible. What's more, Proxima b orbits its star at just 7 million kilometers, completing a full orbit in only 11 days. This proximity means the planet's surface is split between a scorching hot day side and an intensely cold night side. The planet's rotation is tidally locked, meaning one side always faces the star while the other remains in perpetual darkness. Despite this, there could be a limited twilight zone or terminator line between these extremes that offers conditions suitable for life. If we assume the extraordinary possibility that all the factors favoring life align on Proxima b, and that a highly technical alien civilization indeed thrives there, the James Webb telescope could still struggle to detect artificial lights. For instance, if Proxima b's inhabitants use LED lighting similar to ours, their nighttime lighting would have to be 500 times more intense than Earth's to be detectable by Webb. That's a significant if. As some experts point out, in our search for life in space, we might benefit from thinking outside the box. Just because evolution on Earth has produced eyes that see visible light doesn't mean life on Proxima b would evolve similarly. Who knows? Life there might rely on sound waves, infrared, or something beyond our imagination, rendering artificial lights unnecessary. Interestingly, there's also a possibility that Proxima b isn't fully tidally locked. This could lead to more varied rotational patterns and dynamic climate conditions. If the planet's orbit is slightly eccentric, it could exhibit a resonance, similar to Mercury, where its rotation and orbit produce more diverse circumstances. In fact, new climate models designed to simulate rocky exoplanets around red dwarfs suggest that Proxima b could be habitable. Using a supercomputer, scientists created 3D simulations that revealed various potential climates based on environmental factors. When they modeled Proxima b's conditions, the results were surprising. Despite being tidally locked with one side constantly exposed to intense radiation, the planet could still support life. If Proxima b has an atmosphere similar to Earth's and a strong magnetic field, it could shield itself from the severe radiation emitted by its parent star. In this scenario, the planet could even be covered by an ocean stretching into its night side, possibly resembling a giant eyeball planet staring at its star. While this might sound strange, it presents an intriguing possibility for scientists searching for signs of life beyond Earth. For years, researchers have been eager to study this elusive part of the universe, hoping to uncover more details than ever before. Then came the game changer, the launch of the James Webb Space Telescope. One of its primary objectives has been to study exoplanets like Proxima b in unprecedented detail. With its ability to analyze atmospheres, temperatures, and even potential biosignatures, Webb has opened new doors in the quest to answer humanity's biggest questions. Are we alone? What else lies beyond our world? Even as Webb continues to provide groundbreaking discoveries, it reminds us of the vastness of the universe and the limits of our understanding. Proxima b, with all its mysteries, remains a tantalizing subject. Whether it harbors life, simple, complex, or even intelligent, only time and the advancements in our technology will tell. The mission is to investigate the universe with unmatched lucidity, pushing the limits of what we know. Dissimilar to its renowned ancestor, the Hubble, the James Webb Telescope is furnished with cutting-edge infrared instruments, permitting it to peer further into existence and capture what Hubble could not. This update opens up an altogether new wilderness for scientific discovery. What has the James Webb Telescope found? When researchers guided it to Proxima b, they hoped to gather more data about its climate, surface, and perhaps indications of organic life. The fascinating thing here is that, instead of detecting the usual suspects like methane or water vapor, the telescope captured something completely unexpected: a faint glow coming from the planet's night side. And no, this was not just some natural phenomenon like volcanic activity or auroras. This glow was consistent and reliable, something more likely to come from artificial lighting, the kind of lights you'd expect to see from a city at night. This discovery has left scientists stunned. Could this be evidence of an advanced civilization? While it is too soon to jump to conclusions, the possibility that we might have found signs of intelligent life is hard to ignore. After all, artificial lights are one of the few things we associate with developed civilizations, like seeing Earth from space. If Proxima b truly has something similar going on, we might be looking at our first real clue that we are not alone in the universe. Hypotheses surrounding the discovery. The discovery of potential artificial lights on Proxima b is utterly staggering. If these lights truly are the product of advanced technology, it could mean that a highly developed civilization either exists or once existed on this nearby exoplanet. If that's the case, this would be the first time we've found direct evidence of extraterrestrial technology. This is no small revelation. It's not like finding microorganisms or basic life forms. It could signify intelligent beings capable of shaping their environment, perhaps creating city-like structures. This is the kind of discovery that makes you sit up and realize just how vast the universe really is. But as exciting as this sounds, it leaves us with countless questions. If these lights are from a civilization, exactly how advanced are they? Are we talking about a society like our own, one experiencing its own technological developments and struggles? Or is this something far more advanced? The lights cover a large portion of the planet, according to the data from the James Webb Telescope. This could mean one massive city or many smaller settlements scattered across the planet. Either way, we're talking about an organized society, not just random lights here and there. And then, of course, there's the question: how are these lights powered? Are they using something like electricity, as we do, generated from natural resources like coal, solar, or wind? Or, and here's where it gets truly fascinating, have they developed some advanced form of energy that we can't yet imagine? The implications of this discovery. Proxima b orbits a red dwarf star, which is much cooler and dimmer than our Sun. This could mean the inhabitants had to get creative with their energy production, perhaps harnessing energy in ways that might provide clues for solving our own energy challenges on Earth. But what if these lights are merely the remnants of a civilization? Think about it. What if this is a society that once thrived but is now in decline? What might have caused it? The discovery of potential city lights on Proxima b could be a game-changer for space exploration. At 4.24 light-years away, Proxima b is relatively close to Earth in cosmic terms, making it an ideal target for future missions. While that distance is still overwhelming by human standards, in the grand scheme of the universe, it's practically in our backyard. Over the years, there has been growing speculation about sending probes or even manned missions to nearby star systems. Now, with the possibility of artificial lights on Proxima b, things could accelerate significantly. Scientists could develop advanced propulsion technologies to study the planet and its potential inhabitants up close. Broader implications for humanity. This isn't the first time we've searched for extraterrestrial life. The search for extraterrestrial intelligence, SETI, has traditionally focused on detecting radio transmissions or other forms of communication from distant civilizations. However, this new discovery suggests a need to shift our focus. Instead of just listening for signals, we should also look for signs of advanced technology like artificial lighting. Stop to consider the possibilities. What if there are more planets like Proxima b, where city lights or massive structures indicate intelligent life? This could mark the beginning of a new era in the search for extraterrestrial intelligence. Public interest is already soaring. People are captivated by the idea that an alien civilization might be close enough for us to see the lights of its cities. Beyond the excitement lies a significant challenge. The potential discovery of an intelligent civilization forces us to reconsider our place in the universe. Historically, we've seen ourselves as the pinnacle of evolution. But if Proxima b harbors intelligent life, we would no longer be alone. This realization could reshape how we view our responsibilities toward our planet and the technology we create. However, with the thrill comes concern about potential risks. If an advanced civilization exists on Proxima b, would they see us as a threat? Just as we might approach them with caution, they might also be wary of Earth. The path forward. Contacting an alien civilization raises difficult questions about our future, our role in the universe, and how we manage technological advancement. One thing is certain. If these lights are real, they could catalyze global cooperation in space exploration. Studying a planet light years away will require collaboration on an unprecedented scale, much like the teamwork seen with the International Space Station. Countries would need to come together, pooling resources and knowledge for the shared goal of exploring Proxima b, and possibly making contact. We must also consider how a civilization could survive in such a hostile environment. Proxima b orbits a red dwarf star known for its intense stellar flares, which bombard the planet with harmful radiation. If those lights suggest inhabitants, it indicates advanced technology that protects them. They could have developed ways to shield their cities or adapted biologically to thrive under extreme conditions. A new era of discovery. The discovery of these lights opens up endless possibilities, from understanding extraterrestrial technology to re-evaluating our place in the cosmos. Whether this marks the beginning of contact with another intelligent civilization or a deeper understanding of our universe, it's clear that we are on the brink of something extraordinary.